Good morning, good evening, and or good afternoon. Today is Tuesday, September 26th, and this is the Antrea community meeting. For today, we have just a single topic in our agenda, and it's a presentation about running Antrea metric stacks for different Kubernetes version using KPI, and sorry, I don't know if I pronounce it correctly. And yes, so that's the only presentation that we have, and let's go straight to the presentation, which is going to be given by Pulkit. So Pulkit, please go ahead with your presentation.
Hello everyone, thanks Salvatore. I'll share the screen. I hope the presentation is visible.
Yes, it is.
So hello everyone, today I'll be talking about the cluster API WSCI improvements. The agenda that I'll be covering today is the architecture diagram for the cluster API. I'll give a brief on it. Then the feature improvements that have been taken care of, the future scope that we are planning to do related to the KEPA jobs, then a short demo, and then we can have question and answers. Starting with a brief on the architecture diagram. This is a general architecture diagram for the CAPA jobs that we have. So there is inside a VPC in AWS, we have a Bootstrap, we can say a KEPA Bootstrap VM on which a kind cluster runs that act as a KEPA management cluster, we can say. And inside that worker cluster, inside that management cluster, we can create multiple worker clusters. And on that worker cluster, we can run the Antrea test, the matrix compatibility test, or any other test like E2E conformance network policy. So we can create multiple workload clusters inside a management cluster. So this act as a management cluster. And then on the worker clusters, we can have as many number of nodes, like control plane nodes and worker nodes as we want, according to our test. And on these control plane nodes of each cluster, they are connected with a load balancer. So this is a classic load balancer which is there, which is connected to the control plane node balancer, and this can and the Kube API server is like connected with this load balancer. So whenever we query, we are querying for any commands, any kubectl commands. We are not directly running those on like the kubectl. We are connect on the control plane node. We are connecting to the control plane node via the load balancer. So this was done so that we do not expose a control plane node directly to the internet or to the user. We are doing it via load balancer. And then we have the security groups configured for on the control plane nodes, worker nodes, on the load balancer, and as well as on the custom security groups. So there is also one thing that these load balancer, they are connected to the internet gateway for now, but later we'll see in the future scope that we are planning to remove this connection so that ELB is not directly exposed to the internet. Then we have a subnet. So there is a same subnet inside a VPC, which all the nodes are using to get their private IP, and they work on that particular subnet itself. And then this is the general naming that we are using, the job name hyphen build number. For the namespace, and it's the same for the cluster also. We are giving the same name to the namespace as well as the cluster in our present implementation. So this is a general overview of how the architecture of KEPA job is and how the clusters are managed and created. So we are using the kind distribution here because this is the simplest, like this is the simplest Kubernetes distribution that we can use to create a management cluster. And then later, whenever the job is done, like whenever the job is completed, so we have two options. Either we only delete our particular workload cluster and the management cluster remains, or we can also, like if we want to clean up the management cluster, then we can perform the cleanup for the management cluster also. So this is a brief about the architecture of the KEPA jobs. Then moving forward to the feature improvements that I have done. So there was one of the major improvement was migrating the AWS to the service user model from the development user model. So when switching to the service user model, we modified all the configurations for the for the cluster C, like there is a cluster CTL and the cluster AWS ADM resources, and then we have the load balancer instances, the cluster YAML. So we modified few things and we used the IAM roles instead of the actual access key and the secret access keys that were there. So this was one of the things. Then I set up the Kepa Bootstrap VM, installed the necessary environment settings that were related to running the Antrea related matrix compatibility test, and registered it as a node on the Jenkins. So this Kappa Bootstrap VM, which has the management cluster, is registered as a node on the Jenkins, and whenever a job runs, a workload is cluster is created inside that management cluster, and it is and the job is run there. Then the next thing was the setting up the matrix job to run weekly on AWS. So the purpose of this matrix job was to check the compatibility of Antrea with the recent four releases of the Kubernetes, whichever Kubernetes releases are there. So we have basically created two axes. One is for the OS and another one is for the Kubernetes version. So we can add more OSs here as per the requirement. So currently we have the two values for the axis. For this OS, we are testing with Ubuntu 20.04 and 22.04. And we have for the different K8s version 1.25, 26, 27, 28. So whatever, whenever this job is triggered, what happens is a cluster is created with this OS and this particular Kubernetes version. So similarly, it runs in a matrix sort of way. So this OS with this version with all the and other three version, and then this OS runs with all these four versions. So clusters are created accordingly. So the cluster YAML which is there, so it adapts to the OS version and the K8s version, and the instances that are getting provision on EC2. So they will have the clusters that like the one control plane node and the two worker node, they will have this particular OS and this particular version. And then our E2E conformance and network policy test would run, and this metrics will get filled up as per the result of the test. And then we can see that if there is an issue, like suppose there is an issue that there is a failure of job with version 1.26.1 and with this particular Ubuntu release. So we can then, you know, triage the root cause of the error, that why is it not running? Is it some compatibility issue or something? Something related to the configuration settings and all. So this is what a matrix job. So it will run as a cron job. It will run every week on Jenkins CI that we have. Also, like if someone wants to trigger it manually, like if they have made some PR changes and they think that it might affect the compatibility with one of the Kubernetes releases and they want to run this matrix job. So there is a trigger phase also, that is test Kepa AWS, and they can use that trigger phase to trigger the job manually also from their PR. So this also we have provided. Any questions so far? Okay, I get
Yeah,
started.
go ahead, sir.
Then moving to the future scope. So one first thing and the major thing that we need to do is creating a custom DHCP option set for VPC, so that the public IP is not assigned to the resources which are created. So now, for now, when we are using the cluster API and applying the YAML to create a Kepa cluster, so public IPs are assigned to the load balancer, and sometimes they are also assigned, like previously they were also assigned to the control plane instances and the worker node. So we do not want to get them assigned to a public IP. So for that, we need to create a custom DHCP option set and assign it to the VPC on inside which we are creating these instances. For now, we have the DHCP option set that is created, that is using the Amazon DNS servers and the Amazon domain name. So we need to modify it to use our custom DNS server so that this a public IP is not assigned and it is not exposed anywhere. And the next thing which I talked about earlier also in the architect during the architecture diagram, that we need to detach the load balancer from the internet gateway. So these are the two things under future scope. And first of the option, like the custom DHCP option, that is the work is currently going on for that part. And then on the testing side, so we have to configure all the access properly. Like for now, we have not tested the complete matrix that was shown there. So we need to test the complete matrix with all the possible values. For now, we have tested it with the Ubuntu 20.04 with the different versions of Kubernetes. So we need to test the other versions also with the Kubernetes version, and we need to have a full compatibility matrix there. So this is to be taken care of on the testing side in the future scope. So that's all from my side. Now I can go on for the demo if you don't have any questions. So I'll start with the demo. I'll share another screen. I hope my screen is visible.
Yeah, but it's the same as before. It's not another screen.
I hope now
Okay.
it is.
Okay, got it.
You can see that so this is the Bootstrap VM which is there. So and if I get you the node, so this is the management cluster which is running. So it's a single node cluster. It has only the control plane nodes, and if I show you the pods and the namespaces which are there, so we have the Kepa controller manager, that is the cluster API AWS controller manager that is running inside the cluster API AWS system. And then we have the cluster API kubeadm bootstrap controller and the bootstrap control plane manager that are running in the respective namespaces. And then we have the CAPI controller manager. So these are resources, they are created whenever we initialize this as a management cluster with the provider as AWS. So these resources are provisioned there. And then when we trigger the job, so I have triggered the job from beforehand. So this is the Antrea weekly Kepa AWS matrix compatibility test. So currently it is running with version 1.25.1 for Kubernetes and Ubuntu OS version is 20.04. And after the instances are getting created, it runs the Antrea E2E test on it. So you can see like in the instances part. So we have these three instances getting created, the matrix K8s one, which you can see. So one is for the control plane and the other two are the worker nodes instances that are there. And then if I use the kube config, so I'm now using the kube config of the cluster that was created when the job was triggered. You can see that we have the Antrea running on it. And then if I get the nodes, so we have this like these three are the nodes. We have one control plane, the two worker nodes which are there, and we can see the version is version 1.25.1 for Kubernetes. And then the Antrea E2E conformance and network policy test runs as they run usually. So this is how like inside a management cluster workload cluster is getting provision. And now if I want to delete this cluster, so I can delete the cluster from here using the kubectl commands. This will free up the resources that have been occupied by the kubectl, but the instances that were created, we need to do a cleanup from the script for those instances, and we need to delete those instances from a separate script. These instances, when we delete the workload cluster, these instances are not automatically deleted. We need to have separate commands in the script to delete these instances that are getting created and the load balancer that is created. So you can see that this was there is a load balancer which is there, and and on this load balancer we have this instance that is the control plane instance that is registered here. And then whenever kube API server queries something, so it queries to the load balancer, it reaches the control plane node, and all the operations happen like this. This is the process that takes place. So this was a short demo kind of thing. And then so this is the matrix job which is there. We have currently for the testing purpose, I was using only version 1.25.1 for this, but otherwise the entire matrix that I have shown in the slide, so entire matrix will be shown here in the under the configuration option. Any questions?
I have a question on the resource cleanup. So I think if you delete the cluster from the Bootstrap cluster, delete the workload cluster from the Bootstrap cluster, why does it not deleting the related instances from the AWS? I think if it creates those instances from your cluster, it should be deleting those instances after you delete the cluster.
Okay, so what happens is that when we delete the cluster.yaml that is there, and like the entire YAML that we have applied when creating the instances, when we delete that, so it from the kubectl side, the API server, the resources that it was held, like when we perform kubectl get nodes, so we won't get any nodes there. It will free up the resources from there, but it won't connect to the AWS API to delete the instances. So that connection is does not take place. Like it won't connect to the AWS API, and the cluster will still remain there in a running state. So we need to delete it using the AWS CLI commands. That is the AWS EC2 delete instances. So this command we need to use to delete the instances. For now, like there might be an option like we can debug more into it, and we can find if there is a
Understood.
way in which we can delete it directly while deleting the YAML. But as
I
per
think, yeah, I think maybe there is a bug in the CAPA implementation. So if you delete everything directly, it cannot do the cleanup properly. So I think there was originally there was an assumption that in the cluster API implementation that you need to delete the cluster only, and then it will clean up everything for you, and then you can delete the namespace. Otherwise, if you delete everything, when it performs, CPA performs the cleanup, it cannot find your cluster, corresponding cluster, and it will fail to do the cleanup. Maybe that's the issue, because you know that we also use the cluster API for vSphere provider internally, so we run into such issues occasionally. So maybe the CAPA code implementation has similar issues. You can check whether it's possible to just delete the cluster and then whether the resources are cleaned up.
yeah, sure. Because when I ran the test manually, then I ran with the same issue. Like when I was doing the cleanup by deleting the cluster YAML, the Kubernetes released the resources, but the instances were still there. So
Yeah,
I'll check with the code implementation of CAPA if there is
okay.
an issue. Any other questions?
Looks like there are no other questions. So it's been a great presentation, Pulkit. Thanks a lot for sharing this. And do we have any other topic for today? Because that was the only one that we had in the agenda. Is there anything else that you would like to discuss, bring up for review? Well, I believe that this silence seems to explain perfectly there is no other topic. I'll just keep waiting a few more seconds in case anyone wants to bring up something. And I believe that it might be all for today. So thanks everyone for joining, and I wish you a great afternoon or a good evening or a good night for our friends based in the West Coast in the US. So thanks a lot for attending, and talk to you in 2 weeks' time.
Thank you all.
Thanks.
Thank you. Bye-bye. Bye.